Hello, everybody. This is Mr. Mohieddin, and we are having our first e-learning session. As you know, our classes are going to be online now. We're going to be starting to revise for the IGCSE syllabus. The first lesson for today is going to be about thermal physics. We are going to be working on all the remaining topics that we did not finish yet. Before I start talking about thermal physics, I want to talk about how will this e-learning support go on, and I'll talk about a few details. The first thing I want to talk about is the procedure. So the first thing I'm going to do is that I will be posting a revision video about a certain topic of the syllabus twice a week. So twice a week you will find this video on Digital Campus. I also will post its link on Edmodo, so you can find it on YouTube as well. The second thing is going to be an assignment twice a week. After I post the video, there will be an assignment that you have to solve, and you have to submit it on the deadline that I'm going to be putting with it. The third thing is going to be a quiz, also uploaded on Digital Campus. You can find it on the LMS. You have also to do the quiz and submit it on a certain deadline. We are all counting that you are going to be taking this seriously. There's no point if you do the quiz with any kind of help online or a book or a marking scheme. All these quizzes are not going to count towards your external results, as you know. So I'm sure that you're going to be taking this seriously with the time limit and the exam conditions at home. The fourth thing is a discussion forum I'm opening on Digital Campus. So you can go into LMS, you will find the discussion forum where you can put all of your comments and questions that you have on this unit there. So each unit will have its own discussion forum. I'm going to also be answering all of the questions they're going to be asking on Edmodo. So both places I'm going to be available to answer all of your questions. There are some questions I've seen already on Edmodo. I still did not answer them. I'm going to be working on them today. Now, let's start with the main ideas for thermal physics. I'm going to have a list of all of them. The first part, which is the video I'm posting today, is basically on the kinetic theory of matter and evaporation, the ideal gas laws. We'll see if we talk about the temperature and thermometers, or we keep it for the next time. The second part is going to be basically about specific heat capacity, specific latent heat, conduction, convection, radiation, and heat losses, and how to prevent heat losses, and how to insulate an object. These topics shouldn't take so much time, so I'm hoping that in 2 sessions we will be done with all of them. Now, let me start talking about the kinetic theory of matter. The first thing that I want you to know is that the kinetic theory of matter is coming from the word kinetic, energy, which is the movement of the particles. So we are stating that all states of matter are composed of small particles, and these small particles are in constant motion. All the time it is the particles are moving, and each state the motion differs from another one. So in gases, the particles, as you can see here in the animation, that the particles are moving freely and randomly, what we call Brownian motion. This blue sphere is considered to be a smoke particles, and the red ones are air particles, and you can see how it's being hit from different sides. All of this we're going to talk about it now. So the constant motion is something that you really have to focus on. The second thing, it's a question that I've seen a lot, and it's out of 4. So whenever they ask you this kind of question, it's usually out of 4 points. When they ask you, use ideas about momentum to explain how the particles of a gas exert pressure on the walls of the container. When they ask you to talk about momentum, you have to mention that the particles collide with the walls, because as collisions happen, the velocity will change. And a change in the velocity means there's a change in the momentum. So the first keyword is collide, and then change in their velocity, which means a change in the momentum. That change in momentum creates a force. If you are asking how, where is the link? Because we know the impulse momentum theorem, which states that force times time is equal to delta P. So anytime there is a change in momentum, there's definitely a force applied. Now this force on the area of the walls exerts pressure, and it's important to say that the pressure is equal to the force divided by the area. So sometimes they don't ask about all of these details, but whenever they do talk about momentum, you have to do this. Sometimes they say, how does the momentum, ideas about momentum and how it creates a force. You don't have to write the last step. So it depends on how things are. Now, one more thing is about asking you to draw the path of a particle, of a gas particle in a container. I think we all know how to do this. So let's say this is the container. You have to show random motion, but it's very important to show that there is a collision of the walls, not only collision with other particles. So it's important to show collisions with the walls, like here, and collisions with other particles, like here. So it's important to know this. Now, drawing the particles of a solid, liquid, and a gas, I think you're very familiar with this, how the solid particles have to be tightly packed. So they have to be tightly packed. Now, this drawing is not so good because I didn't manage to make them equally sized, but you have to make them equally sized particles. Now, the gas, you have to make sure that they're away from each other, because the gas particles, they have a big separation between each other and no intermolecular forces. The second thing is about the difference between boiling and evaporation. I just want to tell you that that's something really easy, the definition of evaporation, how it happens, but mainly the difference between boiling and evaporation. Boiling happens at a fixed temperature, which is the boiling point. Evaporation happens at any temperature. Boiling takes place throughout the whole liquid, whereas evaporation only at the surface. That's something really important that comes a lot in multiple choice sometimes. Bubbles and the temperature stays constant, whereas the temperature changes. One important idea is that after evaporation happens, the most energetic particles have left, so the remaining ones have less average kinetic energy, which means the temperature will decrease. Sometimes they ask you, for example, we have a container with milk bottles, and there's a piece of cloth that is wet put on top of them. How does this help keeping the milk cold? You have to talk about how evaporation is going to happen from the piece of cloth, so its temperature will drop, and then the temperature of the milk will drop as well. So it's quite important to talk about that too. And then the factors that affect evaporation, there are three things: temperature of the liquid, the surface area, and the movement of air, which is the wind. One more thing is also the drought. If it's a dry weather, it also helps. So these four ideas also should be known.